everyone, and welcome back to our exponential equations lesson. And in this lesson of exponential equations, we are still busy with rational exponents, and in this case we are going to have to factorize. So these are a little bit more difficult than our previous two lessons, but I'll try and make it as easy as possible. Now, the difference in these examples that I'm doing today are that we cannot create one term equals one term with normal simplifying. We would have to factorize. Okay, so just to show you quickly, if I have x to the power of a half minus 3x to the power of a quarter plus 2 equals 0. Okay, and I move the constant term, I will still end up with the following, and it will be a minus 2 on the other side. So this is what it will look like. And if I factorize this side, well, I can basically take out an x to the power of a quarter, and then I will have left an x to the power of quarter minus 3 equals minus 2. Well, this doesn't help me because this is one term equals one term, but when I multiply two things, I want it to be equal to 0 so that it's a zero product rule. So this doesn't help me at all. Okay, so by just moving my constant term, I cannot do anything. So basically, I know I'm going to have to factorize. So, but I cannot take out a common factor. So, will this not be a trinomial? Oh, yes, it is, because the middle term's exponent, that middle term is a quarter, that exponent is half of the first term's exponent. So this is a trinomial we can factorize. So when I want to factorize a trinomial with rational exponents, I always take this middle term's x to the power of its rational exponent when that is half of the first one, and I equate this x to the power of a quarter to k. So I'm going to say k equals x to the power of a quarter. Now, with a little bit of practice, you'll get this done easily. So, all that you have to remember so far, if you know it's a trinomial, how do I test it? It's that the x's variable of the middle term must be half of the exponent of the first term, right? Okay, so I'm just going to take this middle x with its exponent, and I'm going to say k equals to x is a quarter. And now, 2 quarters go into a half, because a quarter plus a quarter is a half. So this will basically be k to the power of 2. Okay? And then minus 3k plus 2 equals 0. Because all I did was, because if I take x to the power of a half, it is a x to the power of a quarter times a x to the power of a quarter. Let me just quickly show you. X to the power of a half is x to the power of a quarter times x to the power of a quarter. How do I know? I simply write the x, a quarter plus a quarter is a half. So this will be a k times a k, which will be a k squared. That's where the k squared comes from. Okay, wonderful. Now I just have a normal trinomial I need to solve. So this will be k squared, this will be a k and a k, this will be 2, so it's 2 and 1. What do I need to get? I need to get a minus 3. So k times 2 will be 2k, k times 1 will be 1k, so it must be a minus 2 and a minus 1k, and carry over the minus, carry over that minus, so we've got k minus 1, k minus 2. So this will be k minus 1 and a k minus 2 equals 0. Wow, now I've got a zero product rule. So therefore, k minus 1 equals 0 or k minus 2 equals 0. Therefore, k equals 1 or k equals 2. Okay, great. But we didn't work with k initially. K is x to the power of a quarter. So x to the power of a quarter equals 1 or x to the power of a quarter equals 2. And what do we do if we've got x to the power of a rational exponent? We raise it to that exponent's reciprocal, same as on the other side, right? Okay, so look very carefully. I'm going to do all of them all in one. So this will also be 4 over 1 and this will be 4 over 1. So remember, two different sums, two different equations. So this will simply be write the x and then 1/4 times 4 over 1 is x to the power of 1 equals, and then 1 to the power of 4 is just a 1, or in this case it will be a x because 1/4 times 4 is a 1, and then equals to 2 to the power of 4, which will be 16. And there we go. So x can either be a 1 or x can be equal to 16, and then that sum or equation will be true, will work out. Okay, great. And now for those of you who are confused with the k, please just practice this a bit and see if you don't get the hang of it instead of just giving up. And I'll also show you quickly what's the other way of doing it. We could just set up this as a x to the power of a half, and this is a 2. So this will be x to the power of 1/4, x to the power of 1/4, which is 2 and 1. And then we want actually minus 3x to the power of 1/4. So those two gets multiplied, those two get multiplied, and we end up with a 2x to the power of 1/4 and 1x to the power of 1/4. Both must be minus, minus, carry the minus over, carry the minus over, and then we end up with this. And look closely, x to the power of 1/4 minus 2, and x to the power of 1/4 minus 1, and we will exactly end up with x to the power of 1/4 is a 1, because that minus 1 will go to the other side if we equate it the same. So you could do it like that as well, or you can use the k method, which is very useful in later grades as well. So I hope you could follow. Let's go and try another example. Now here is an example for you to try and use the k method, because now again, if I move the plus 8 to that side, it becomes a minus 8. We still have two variable terms. We want one term equals one term. We can't, because we cannot subtract those two variable terms from one another. So now we know we have to factorize. So it doesn't help I take the 8 to that side, because we don't have a zero product rule then. So this is going to be a trinomial factorization. So again, is it really a trinomial? Yes, because a sixth is half of a third. And you can try this, because if you take a third and you simply divide it by 2, you'll see that you get a sixth. So this is a trinomial, because that middle term's x exponent is half of the first term's exponent. So what I'm going to do is I'm just going to say k equals x to the power of a sixth. And then basically this will become k to the power of 2 minus 6k plus 8 equals 0. Again, why? Because x to the power of a third is the same as a x to the power of a sixth times an x to the power of a sixth. And then this will give me x. And look again, a sixth plus a sixth is a third, right? So just to show you again, there we go. And this means that if this is a k times a k, we will have a k squared, right? Okay, great. So that's where the k squared comes from. So now I just do a normal trinomial, and this will be k squared. That will be 8. So k and k, 8 and 1, 4 and 2. And what do we want? We want a minus 6k. So that is 4k, that is 2k. So it will be a minus 4 and a minus 2k gives me a minus 6k. Carry over the minus, carry over that minus. Those two go in brackets, those two go in brackets. So I've got a k minus 4 and I've got a k minus 2 equals 0. So therefore k minus 4 equals 0, or k minus 2 equals 0. Therefore k equals 4 or k equals 2. Now what is k? K is x to the power of a sixth. So x to the power of a sixth is equal to 4, or x to the power of a sixth is equal to 2. And therefore we raise this side to its reciprocal, 6 over 1. We raise this one to 6 over 1. And then we get x equals to the power of 1, 4 to the power of 6, or we simply have on this side it will be x, raise it to its reciprocal, raise it to its reciprocal, and again we've got x to the power of 1 equals 2 to the power of 6, and now we can just simply work it out. So x equals, and this will be 4 to the power of 6, and it gives me 4096, or x equals to 2 to the power of 6, which is simply 64. And that is it. So there we go, and you can test those answers in there with your calculator to see if you get the same. So yes, I know it's a bit difficult. I have to put them in here because there's always a chance you might get one of these. And if you can spot the trinomial, the k method is quite easy. The k will always be equal to the middle term's x to the power of whatever it is, as long as that is the middle term that you use for k. And then remember, then the first term will just be k squared. Okay, great. So hope to see you again soon. Keep practicing. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.